In this video, I'm going to show you guys how to solve an absolute value equation. Now, to solve an absolute value equation, let's remember what absolute value is. The absolute value of anything has to be a positive number. Okay, so it's the distance that a number is from zero. So we're looking for some number or numbers that when we plug them in for x and we take the absolute value of it, it'll give us a positive answer. And to do that, remember that there's actually two answers here that could work for this problem. When whatever is in here is equal to 13, if we took the absolute value of it, that would be one possible solution to the problem. So if whatever's in here was equal to 13, that would give us one answer. But then there's another possibility. If whatever is in here is equal to negative 13, that would also work, because remember that if this all equaled negative 13 and we took the absolute value, that would give us positive 13. So there's going to be two separate equations that I can solve here to try and find my answer. So the first step is to split it in two equations. One where the right side is positive and one where the right side is negative, or one where the right side is your regular, starting out after the equal sign, and one where you have the opposite of whatever's after the equal sign. Now, going ahead and solving here, just like an equation, I'm going to subtract 9 from both sides over here. So I'll get negative 2x is equal to 4. And if I divide by negative 2 on both sides, I'll get x is equal to negative 2. Okay, over here, I'm going to subtract 9 on both sides, and I'll get negative 2x is equal to negative 22. And if I divide, that should give me x is equal to 11. Now, always important to check your answer here to make sure this works. So I'm going to go back to the original problem, and I'm going to fill in my first answer here. And I'm going to fill in my negative 2 to make sure that this works. So 2 times negative 2. Oh, I'm sorry, I missed my negative sign on this. So that was supposed to be a negative 2. Let's go back. So negative 2 times negative 2 should be 4. 4 plus 9 is 13 in the absolute value here. So the absolute value of 13 is in fact equal to 13, so we know we've got the right answer. Okay? Now, next one, let's check 11. So the absolute value of negative 2 times 11 plus 9 is equal to 13. Now this one's a little less obvious, but check it out here. Negative 2 times 11 is negative 22. And negative 22 plus 9 is equal to negative 13. And remember that when you take the absolute value of a number, it makes it positive. So we do, in fact, here have 13 is equal to 13. So we know that both of these answers are correct. It's very important to check your answers in these problems to make sure that you're getting the right answer. There are some solutions that can sometimes be what we call extraneous, meaning you solve for it, you do all the correct work, and you get these answers, but they don't actually, when you plug them back in, work. So you have to make sure you check your answer. Okay, next one will be a little bit more complicated. We've got this x plus 2 part in the absolute value here. And the key is we're going to have to start by isolating the absolute value part before we split it up. We're not allowed to just make this negative 17 and positive 17 when we split it in half. We're going to have to actually isolate the absolute value first. And to do that, think of this as just one big variable, like an x or a y or something like that, and you're trying to get this by itself. The first thing you would have to do if you were isolating this, if you had this as like a 2, let's say a plus 4 is equal to 17, and I was solving to isolate this a or this absolute value, the first thing I would do here is subtract 4. So that's what I'll do first. I'm going to subtract 4 on both sides. So that gives me 2 times this absolute value part is equal to, and then we'll subtract here. That should give me 13. And now we're almost there. What we have to do now is divide each side by 2. Okay, so this is functioning now like a 2 times something is equal to 13. So we have to divide both sides by 2. So that gives me, if I cancel this here, the absolute value of something plus 2 is equal to, I'll write this as a decimal for this part. Only now are you allowed to split up your absolute value. Once the absolute value is the only thing on this side, you can split it up. And again, we have two possible answers. One where x plus 2 is equal to positive 6.5, and one where x plus 2 is equal to negative 6.5. I apologize if you can hear Sputnik the cat here. He might be meowing in the mic pretty soon. What we're going to do next is, again, solve like we did before. We'll subtract 2 on both sides. These will both solve exactly the same. And we get x is equal to 4.5. And we're going to get x is equal to negative 8.5. Okay? And what I want you to do is take a second, plug these back in and check them to make sure that they work. Okay? They should. So take a second and plug those back in to make sure that both of those answers are correct and that they will solve the problem for you. I'm going to move on to 2 more examples. Okay, the first one here of these 2 examples will be x plus 5 in absolute values is equal to negative 1. Let's just, if you want to pause the video here, give this one a try yourself, and then we'll talk about something special with this example. If you need a second, you can pause it. And I'm going to just go ahead and get right to it here. So x plus 5 we would have is equal to negative 1. Sorry, I should have dropped my bars. Once we split it up, the bars go away. Since the absolute value is by itself, I can start by splitting it up right away. And then we've got x plus 5 is equal to positive 1. Now, from this point, again, if I subtract 6, I'll get x is equal to, subtract 5, I'm sorry, we'll get x is equal to negative 6 for our one answer. And if I subtract 5 on the other side here, I'll get x is equal to negative 4 for the other answer. And you might think that this is great, all well and dandy. This was easier than the last problem. It's actually not. So you got to be careful. Unless you know what to look for, we actually are missing something here. And let me show you what it is. Let's take our answers now and check them like we have with the previous examples. So I'm going to plug in that negative 6 plus 5 equals negative 1. And let's check this out. So negative 6 plus 5 is negative 1. And the absolute value of negative 1 is 1. These two are not equal. So we know right now that this solution is not going to work. X's cannot be equal to negative 6. It didn't work when we checked it. Let's try this other one. So we haven't made a math mistake in our solving, but we're kind of missing something here. Let's check the other one. Negative 4 plus 5 in absolute values is equal to negative 1. We'll add these two. That gives me 1 when I add those two. And then the absolute value of 1 is still positive 1. This one actually doesn't work either, so we know that this solution doesn't work. So let's actually go back to the original problem and just use our brains here for a second. And if you want to take a look at what we actually have here, you can pause the video before I kind of explain this to see if you can figure out what you think the answer is going to be. And for those of you who didn't pause it, or if you're back, welcome. The x plus 5 part in absolute values. No matter what is in an absolute value, it has to come out as a positive number. Okay, so whatever this x plus 5 is, doesn't matter what it is, that needs to come out as a positive number. That can never equal a negative number. So in this case, no matter what you plug into those absolute values, you're going to get something positive. It cannot be equal to anything that's negative. So if you ever see an isolated absolute value equal to a negative number, in this case, this has to be a no solution problem. Okay? There is no possible number you can plug in for x that will ever make that statement true. Okay? And that's why we go back and check our answer. If you check your answer and both answers don't work, you either made a math mistake somewhere along the way, or you might be looking at a no solution problem. Okay? Now, if you're an Algebra 1 student, you could probably stop here. If you're an Algebra 2 student, you might see examples like this as well, where you have variables on the other side. If you have this in your math class, it might be good to look at these. We've got 2x minus 3 in absolute values is equal to, well, now we have variables on the other side. Our absolute value is isolated, though, so we can start right away by splitting this up. And the same rules are going to apply. I've got 2x minus 3 is equal to, we'll leave this side the same, x minus 6. Here's where the other side is going to be a little tricky. It'll be 2x minus 3 is equal to, and just like before, we're going to take the opposite of this side. So it'd be x minus 6, and we're going to actually have to flip all the signs over here by distributing a negative 1 in here. So we're going to just take the opposite of this side over here. So we'll solve the left here first. This will give me 2x. Oh, I'm sorry. Let's go back here. Let's just start by subtracting x from both sides. So that gives me x minus 3 is equal to negative 6. And then if I add 3 to both sides, one possible answer here is going to be negative 3. Going over to the right side, I'm going to distribute that negative 1 first. Again, the other possibility that I have to think about is if that side is negative, or if we have the opposite of this side. So we have 2x minus 3 is equal to, remember that distributing negative 1, all that does is just flip the signs of your numbers. And now we'll go ahead and add x to the other side. So we'll get 3x minus 3 is equal to 6. And now I'm just going to add 3 to the other side. So I'll get 3x is equal to 9. And when we divide by 3 here, we should get x is equal to 3. Now, important, again, to check your answer, make sure that there's no what we call extraneous solutions. When you have examples like this, it's possible that one answer might work, but the other one doesn't. So if we have an absolute value equal to something with x's on the other side, very important to check for extraneous solutions in these examples. So we'll go ahead and do that right now. Let's check the first one. We'll do this up in the corner. So we'll do 2 times negative 3 minus 3, and we'll do this in absolute values here, is equal to negative 3 minus 6. So 2 times negative 3, that's negative 6 minus 3 in absolute values. And over here, we'll just simplify this right away to negative 9. And then this will actually also simplify to negative 9. But this is in absolute values. And we already know that anything in absolute values has to be positive, so it cannot equal a negative number, which actually means that this solution of x equals negative 3 is extraneous. It's not a possible answer to the problem. Let's go ahead and look at this next one. Okay? So we'll check this one. Let's see, 2 times positive 3 now, minus 3, in the absolute values is equal to 3 minus 6. Now, let's check it out. 2 times 3 is 6. Okay? Equals, this would be negative 3. And you might also notice on this one that 3 is not going to work either, because this would be positive 3 and this would be negative 3. So actually on this one too, we've actually just ran into another no solution problem. There is no answer to this problem that will work. Now, it's possible that one of them may work and the other one may not work. It's possible they both will work. But on problems when you have these x's on the other side of your absolute value, you have to check them both to make sure that one, none, or both of them do work.